is, first of all, uh, is everyone familiar with the IFC structure, like the hierarchy of it? So if not, here's a basic overview about how each and every elements are organized of IFC. So IFC is a 3D file format similar, like the proprietary formats like RVT by Autodesk. So each and every program needs to store the geometry information, material information in a format. So if you in web-based application .gltf.obj is a format, because using that format you can reconstruct that geometry in other applications and render it and use it for your own use case. So this is what we are dealing with. We can apply the same workshop logic for other 3D models, same pipeline, and use it for different workflows. So the easiest way to chat with a 3D model is just copy paste your IFC data into that into OpenAI, and I'll show you soon. You will run into this problem where I just did for this workshop. Okay, we have a sample IFC file here, and I just, if you click here, so this is from the GitHub link I shared, and if you click copy raw file and paste it in OpenAI, you'll receive messages like this. The message you submitted was too long. So why is that? All the LLMs have a input message limit, so like they call it input token limit. So when you have small or like big 3D models, soon all the geometry information and everything reaches the input size limit. So you can't just do Q&A. So problem number one, lack of uh, input context. Problem number two is you can't do complex operations with OpenAI. So let's say if you want to find the highest door or like total square feet area of a slab, ChatGPT doesn't have, LLM don't have in general compute capabilities. So you always have to do additional operations to do all those operations. So let's say you want to create a pie chart or other complex scenarios or make a Power BI dashboard. You can't do it in ChatGPT. That's why you need a programmatic way and a different approach to get those insights from your 3D model. And so, what's the solution? That's where we are in this workshop for. So, here's what we're gonna go through during the hands-on session. So we have a IFC model. LLMs need data in textual format. So we're gonna convert it into CSV, and using CSV, you're gonna store it into the database. And we're gonna solve that problem of very high context of the 3D model by not passing all the information, but uh, there's some like background noise I could hear if someone. Okay, thank you. Uh, so how do we solve the problem of, okay, passing all the building information related data? So if I want, give me the largest door. Since if I only pass to LLM the door related information and reduce all the noise and ignore all other information, then I solve the problem of the context. So the way we do is we convert the Excel data into SQLite database, and then when a user have a query, how many doors, we make a database query, give me information about this door, and we then execute that query. Let's say give me list of all the doors. So the database LLM will convert that user query into a database compatible query. We execute that database query, take the result and give it back to LLM to summarize that query and give us in a human readable answer. So step one, storing in the database. Step two, converting the user input into SQL query and then execute it, summarize the result and give it to the. And there are a few interesting software engineering things you have to do. Like for example, if you just say, give me door details, but in your database, uh, in simple terms, assume your database is an Excel. So uh, if let's say you have a query related to door, but your Excel heading for that column is IFC door. So if you want, and basically, maybe this is a good analogy. All we are trying to do is a good filter on your Excel data of 3D model in IFC form. So if I want door related filter, I have to go to door related column in Excel, apply that condition of filter, find that particular ID on which story, and whatever result I get, I summarize it. But there are multiple challenges in this problem. What if the user query is in Portuguese indoor, but your Excel is in English? And so if you apply, just take the user query of door in that language, you won't be able to do filter. So the way you solve that um, problem of different naming techniques of user and your Excel uh, database is by passing the schema. Like I'll just pass the column names for my database into the LLM context. So now LLM will know that all the door related queries is under the column name IFC door. So if someone asks how many doors, total number of doors, I just won't look for column door. I will look for column IFC door. So is everyone on the same page about why we're storing in database, how we are using the database schema is basically all your column names, and how that will help us to generate a relevant SQL query. Amazing. All right. So in summary, so we are gonna do the data processing layer. IFC file, there's a library, Python library called IFC Open Shell. We're gonna convert that data into pandas, which is another uh, Python library for organizing it, storing it in CSV file, then to SQL, and then we'll be able to query structure. And in the user interaction, it's this diagram where user asks a question. We first use LLM to create a SQL query, and then use another, and then execute that query, and then use another LLM call to summarize the user query, and then return it back to the user. So this is what we're gonna do hands-on during the workshop and in the script. Cool. Uh, so in the GitHub, any questions up until here? Okay. So for next steps, all you have to do is click on this open in collab. Uh, in Google Colab, when you open, it will look like this. So one good insight is you can even use the GPUs in Google Colab. So if you have this change uh, runtime type, you can select GPU. But well, we don't need GPU for this, but for future machine learning like related things, you can leverage this capability of Google Colab. So has everyone opened Google Colab? Just do a quick comment in the chat. So I know you're following.
Do we need to click on the connect button? Because yours shows reconnect and mine shows connect.
Yeah, yeah. Because I used just click on connect or reconnect,
Okay.
whatever option shows, and we will be able to do.
Mayur,
Yes.
can you please share the link again if it's possible?
Yeah. So I'm gonna share the link directly in the chat as well, and or either you can go to uh, GitHub and click here.
Thank you.
Amazing. And also for context, so there is this IFC sample file here. We gonna, if you wanna see how it looks like, this is the file we are dealing with. I just uploaded this in IFC viewer. So this is how the model looks like. And if you, oh, and you saw already, we saw the IFC schema, and this is how the 3D geometry is composed and defined in the schema. All good. So we're gonna install two libraries. So pip install, pip is like a Python package manager to install various different libraries. So you can use those functionality and you don't have to write those code from scratch. So yeah, this is the easiest part. All you have to do is click on play button and now you're a Python programmer. Like, okay, uh, like just on the experimentation side, you still have to learn. But I'm just saying, in using ChatGPT or Cursor or whatever platform you use, you can really start building your own custom applications. So
So you've prepared this page for us, right?
yeah, I like most of the work is so I was uh, I asked Joao,
Hmm.
who is an instructor at IAC, to co-teach this workshop. Unfortunately, he has some commitment at this time, so we both have worked on this problem, and he solved this problem using SQL approach, and I solved this using a pandas approach. And just for the sake of simplicity, uh, it made more sense for an SQL approach for this workshop. So
Okay.
yeah, but yeah, it's custom prepared by us.
Okay.
Like, yeah,
But essentially, we need to install this IFC Open Shell and
yes,
and
oh
Open AI.
yeah,
Okay. So that was the first step. And we clicked on the play button. Once it's done, there's a green check mark against it?
yes,
Okay.
yes. So it
Okay.
means you have played, and this is the time it took to play. So
Okay.
we have that, and you saw the IFC sample files. So in Google Colab, if you click on this folder, you will see all the files we're gonna use. So, but first, let's do a high-level overview about how this IFC Open Shell works. So, if you click on this link, and I'll just do a, so basically, IFC Open Shell provides components that can help us get insights and do various getting information extraction from IFC model. So let's say first you'll just share the path of your IFC model, and then if you want all wall types, this is the command, or door occurrences. So if you want to count the total length of doors in your 3D model, this 5 lines or 6 lines is all you need. So this is how it's simple, like to get insights from your 3D model. And you can imagine now how you could plug this with Power BI or other dashboards. Okay, if you want to create a bar chart of how many different names or like unique instances, how many floors in this building with and map it with total square foot. All this, if you read this documentation, it's very straightforward to do with your 3D model. If you want like how many, what's the materiality, what's the length of common, like average length of all the walls and things like that. So this is very simple documentation. You just copy paste it in Colab, and then you can test those functionality. So this is high level overview about the library. So first, we don't have the 3D model IFC. So this command, if you click, uh, we will download this. And if you click on this refresh button, I'll quickly add someone on the call. Okay. Yeah. So once you run, you will see this. So git clone, basically whatever GitHub repo we saw, it's basic cloning it locally in our uh, system. And once you click on refresh, you will see all the files which we saw on GitHub here. And when I am clicking, you can control like copy path, and it will have this path URL. So we are now gonna read this IFC sample file, and this is the command for that. And the next line, if you run it, it's following along the diagram I shared, where you're gonna convert this file into an XLS file. And here, just for the sake of simplicity, uh, we are removing other columns actually. So there is a command. I'll do this custom from rich import. So right now this is a very long print statement. We can beautify a bit by just adding this command. So we'll see these are the columns we ignored. And if you refresh this, you will see the Excel file we created from the IFC file using this code. So
Mayur, do we want do we put this from rich import print in our code as well?
yeah, you could do this. It will just gonna make it more legible for us for future print statements. So yeah, it won't harm. You can just do it.
Maya, there's a
Yeah.
there's an error that I'm receiving. It's saying that there was an error loading this notebook. Ensure that the file is accessible and try again.
Wait.
And request had invalid authentication credential. Expected OAuth2 access token.
Huh. Anyone else
Um,
facing this? Can you try maybe this link again?
yes, wait.
How about others? Are they able to follow along? Uh, okay, okay, cool. Any other questions related to this? Why we do? What's the, because we all are domain experts. So you can ask anything. Any there might be few people who are new to this programming. I might be throwing pandas and other terms, and you're like, what the hell is this guy talking? So feel free to ask questions.
I think it might be for the restrictions for Iran. I'm not sure about that. So I
Oh,
will follow what oh no no no. Somehow it's loading. I'm not sure. Something is loading, but not the actual code that you're showing right now.
uh,
Okay, just let's move on. I will follow
yeah,
your
we can
tutorial.
coordinate
Okay,
later. Yeah.
okay,
So
okay. Thank you.
uh, so this is the part where we are removing these columns, and if you like the way either you can double click or click on this part and you can download this file locally. So you will see how we just trimmed a lot of this other extra things from the IFC. And I also pulled the model. So this is the format which you would look. It's not super clear because I was opening online. But this is how from IFC model, this format, we converted into an Excel format. So it has all the information about levels, type. So even for your personal debugging, uh, it's good to know what data you're dealing with when you are trying with your own IFC models. All right. So SQL, I could talk more about why SQL, what are the different databases, but it's not the focus. It's just basically we are gonna create a local database where we'll store all this information from Excel, and you will, once we play this, you will see soon the file format in the uh, document file browser, that how it created. So we're getting all the column types, storing it in the SQL, because in future with LLM, we're gonna you will see how from this here it's not legible. We're getting the column names from the database, which will help us align the user query and the SQL. So you can click it here, simple play here, refresh, you will see .db format, which is just getting the Excel data in a SQL format. And if you have done rich print, you will see much more legible way of what are the various information we extracted, like Windows. Okay, so step one, converting the data from IFC to a format which is LLM compatible. And now once it's LLM compatible, uh, we have to set up a pipeline to uh, get the right data at the right time based on the user query. So here's this function of schema. You can just in a simple term like column names. So, and let's say if I want to get all the door information, let's say related to dimension, step one is execute create me SQL query that can give me all this column. So the way it will work is it will create an SQL command. Hey, get all the rows of column name dimension. And then once we get the command, execute SQL query, will get that command string and fetches all this information of numbers. And then we'll do LLM summary. So that's it. Here, finally, the thing which we did, just quickly add. Uh, the At the beginning of the workshop, I asked you to get the API key. So here's where we will place it. So you will see a box right here. So all you need is get the key, copy it and paste it in this bar. And now your OpenAI model is set up. So we are using GPT-4o, but you can also use 4 for a mini. Uh, it won't make a big difference. So task one is take a user query, which we are defining user function. So since OpenAI, the way it works is it's a chat interface. User, the way in the API you define it is here's a system message. So you give a goal to this LLM uh, agent, and then you get the user query, and then when LLM answers, that answer is stored as a role assistant, and then you can ask another follow-up question by saying role user question. So this is how the chat interface goes on. So you system user assistant, and that's how in ChatGPT when you converse, that's the whole thing working. So here the goal is we're not asking LLM to just get all the content. We're asking LLM to create a a query, an SQL query. So that's what basically the prompt is about. Think about what query in the database we should fetch. So in simple terms is we are asking not to get the Excel data. We're asking what filter we should do it in Excel, and we'll go to Excel and we'll implement that filter, get the data. So that's the first thing. And second LLM call is you got the query. So yeah, this is a good example. For example, if you have question, what is the area of largest slab? The SQL query from this LLM call will give like this: get the dimension area from the IFC column and sequence it uh, descending order by dimension area. So here it will go to that dimension area column, sort it out in lower, and we'll get that out. And once you you get this, we'll pass it into this execute SQL query function. And when you pass this string in execute SQL query, it will give this answer. Oh, this is the ID and this is the area how much I found. And then we just make another LLM call to summarize. Oh, the largest area of this ISC slab is this. Okay, so we run this, and this is where you change your user question. Uh, and LLM will chat. So this is very, very simple questions. Uh, Me and Huawei have added a lot more capabilities on top of it, but it's for other work. So how many total doors in this project? And all it is query. Okay, I think I forgot to run one cell. This one,
Yeah, I also
and
got an error. Which one to to run? Okay.
yeah, maybe I you might have missed. So
Yeah, I got it.
cool. Yeah. So see, this is how, like, if we just have copy pasted that IFC, LLM would have hallucinated. But here we are asking LLM to just create the SQL query. And since SQL, we have control over deterministic way of doing it, it's going to give us query and LLM is summarize. So you avoided the whole hallucination